Hello everyone, you're welcome to solve this nice algebra problem, which is a squared minus b. This is equal to 13. Let's call this equation 1. We have b squared minus a, this is equal to 13. Let's call this equation 2. And given that a is not equal to b, a is not equal to b. So the first step here to solve for the value of a and b, the first step here is to subtract equation 1. Let's subtract equation 1 and equation 2. So here we have a squared minus b, subtract b squared minus a. This is equal to 13, subtract 13. So here we have a squared minus b squared, then minus times minus a, this is plus a. This is equal to 13 minus 13, this is equal to 0. So you will have a squared minus b squared plus a minus b. This is equal to 0. Now, you find that a squared minus b squared, this is in the form of x squared minus y squared, which we can express as x plus y, x minus y. So applying this property, then here we'll have a plus b, a minus b, then plus a minus b. This is equal to 0. But a minus b is common here, so let's factor out a minus b, so that here we'll have a plus b plus 1. This is equal to 0. So here we have two parts. The first part is a minus b. This is equal to 0. The second part here is a plus b plus 1. This is equal to 0. So in this case here, a is equal to b. And this violates the condition that a is not equal to b. So this part is rejected. So we reject this particular part. So this part is rejected. So now here we have a plus b plus 1 is equal to 0. Then let's make b to be the subject of the formula. So b will be equal to negative 1 minus a. Let's call this equation 3. Now from equation 3, let's substitute equation 3 into equation 1. Equation 1, we have a squared minus b, this is equal to 13. Let's substitute this. We have equation 1, which is a squared minus b, this is equal to 13. Substituting the value of b here, this means we have a squared subtract b, which is actually minus 1, subtract a, this is equal to 13. So this is a squared, minus times minus, this is plus 1, minus times minus a, this is plus a, this is equal to 13. So let's take 1 on the right hand side, so that we'll have a squared plus a, this is equal to 13 subtract 1. So we have a squared plus a, this is equal to 13 minus 1, this is equal to 12. Then let's take 12 on the left hand side. So here we have a squared plus a subtract 12, this is equal to 0. So this is a quadratic equation. This is a quadratic equation with the value of a equal to 1, b equal to 1, and c equal to minus 12. So let's proceed from here. Now, we can solve this quadratic equation by applying the quadratic formula so that a1, a2 will have quadratic formula which is minus b plus or minus the square root of b squared minus 4 times a times c, all this divided by 2 times a. So this is the same thing as minus 1 plus or minus the square root of b squared here, this is 1 squared, minus 4 times 1 times c, which is minus 12. All this divided by 2 times 1. So this is equal to minus 1 plus or minus the square root of, this is 1 squared, which is 1, subtract, we have minus 12 times minus 4. This is now plus 48 divided by 2. So this is equal to negative 1 plus or minus the square root of 1 plus 48, this is 49, divided by 2. So this implies that a1, a2, this is equal to minus 1 plus or minus the square root of 49, which is 7, divided by 2. And therefore here, we have that a1 is equal to minus 1 plus 7 divided by 2. So this is equal to 6 over 2, and this is equal to 3. Then we have a2 is equal to minus 1 minus 7 divided by 2. So that now a2 is equal to minus 1 minus 7, this is minus 8 over 2, and therefore this is minus 4. So we have a1 is equal to 3 and a2 is equal to negative 4. So now if you recall here, we end that equation 3 here is the same thing as b is equal to minus 1 minus a. So we have b is equal to minus 1 minus a. So b1 will be equal to negative 1 subtract a. And a1 here is 3. So this means that b1 is equal to minus 4. So this implies that a1, comma, b1, this is the same thing as 3, negative 4. So this is the first set of solution. This is the first set of solution. And then b2 here will be equal to negative 1 minus a2. And this is minus 1 minus a2, which is basically equal to minus 4. So minus minus 4. And this is equal to minus 1. Minus times minus 4, this is plus 4. And this is equal to 3. So this implies that a2, comma, b2, this is equal to negative 4, comma, 3. So we have two sets of solutions here. We have these two sets of solutions, and then we can verify to see if this set of... Now, let's verify that these two sets of solutions satisfies the equation. So a1, b1, this is 3, negative 4. a2, b2, this is minus 4, 3. Now, if you recall here, we end that equation 1 was a squared minus b. This should give us a value of 13. This was equation 1. We have equation 2 is b squared minus a. This should also give us a value of 13. So we can either use equation 1 or 2. So with reference to equation 1, which is a squared minus b, this should give us a value of 13. So from the first set of solution, a1, b1, which is 3, negative 4, we'll have here 3 squared minus b here is minus 4. This should give us a value of 13. So this is equal to 3 squared, this is 9, Minus times minus 4, this is plus 4. And this should give us a value of 13. So this clearly shows that A1B1 satisfies the equation. Let's check A2B2. We'll have negative 4. Here we'll have negative 4 squared. Subtract B, which is 3. This should give us a value of 13. Minus 4 squared, this is 16. Subtract 3. This should be equal to 13. 16 minus 3, this is equal to 13, which is equal to 13. So the left hand side is equal to the right hand side. And that implies that these two sets of solutions satisfies the equation. So kindly follow the steps, like this video, and subscribe. Please subscribe, like and subscribe.